In 2017, the Philippines joined the Paris Climate Accord. In doing so, it committed to reduce greenhouse gas emissions by 70% and to increase renewable energy sources to 35% by 2030. The Philippines' commitment to a renewable energy transformation opens up many opportunities for German companies to share their knowledge, experience, and technical expertise. One such company is Lipp GmbH, and its expertise is biogas production. Granted, biogas currently only contributes a small percentage to the renewable energy mix here in the Philippines, but according to Mr. Lipp, CEO and owner of Lipp Company, there is a huge untapped potential for biogas production. I'm excited to have Mr. Lipp on the podcast today, and I can't wait to pick his brain on biogas, pineapples, and anaerobic digestion. Mr. Lipp, welcome to this podcast. It is a pleasure to have you here with me today.
Good day. The pleasure is on my side.
Mr. Lipp, before we dive into the potential for biogas here in the Philippines, I would like to learn a little more about your company first. I know that Lipp built the first biogas plant in Germany back in 1971. Now, fast forward to today, and Lipp Company is a successful and internationally recognized biogas tank producer. So tell me, what is the philosophy that has been driving the company over the past 6 decades? What is your secret sauce?
This is a very good question. And I think one secret lies in this case in the family business itself. It is with me now in the 3rd generation, and it was founded by my grandfather. And it was always thinking forward. We were not thinking about only the business that you have or can do on today, but also on problems that you might face in the future. And as we developed products for silos and tanks in that time, there was a first problem coming up in Germany as well. It was a big oil crisis in the 70s that raised the question, where is our energy coming from? And my grandfather at the time was thinking ahead and having the idea of walking into farms where our products were sold, that there's a lot of organic waste. And out of organic waste, you can do biogas. That's a 1,000-year-old knowledge that was done for generations already, but it was not done on an industrial scale. So by that, it was the idea to purchase a farm by ourselves and make tests how to generate biogas on a small industrial scale biogas plant out of the residues of a farm. And this was not an easy process, because to face the challenges of making biogas, you have to do also correct mixing and heating, if you look at the technology, to allow the bacteria to generate the biogas. And this forward thinking and trial and error before we bring our products to the market made us a successful company. And we always looked ahead and did the research and what to do next, and looked ahead 5 or 10 years instead of just 1 year. And that way we were able to develop lots of technologies in the field of biogas, in mixing, in tanks, in digesters. And still today we develop new products with our family, with our team, and implement them worldwide with our crews.
I'm just trying to picture you and your grandfather walking over the farm and very hands-on trying to get some testing done there. So basically the crisis became a blessing in disguise and helped the company to be, as you said, forward-thinking, and that applies until today. Also, your company has already realized more than 30,000 projects worldwide. So what do you think makes the Lipp construction technology so special to achieve such a milestone?
I think the solution and the success lies in the simplicity in the end. It is easy to have an idea about the end product. The question always comes how to reach this solution on the easiest and fastest way possible. And the technology that was developed by our company is to produce tanks and silos out of a steel strip fully automatically with machines on site. And this on-site production in an automatic way made us very unique at that time already, while everything was more labor intensive from other technologies available. Now, these automated machines first were much more complex, and also here it was a trial and error process and a lot of development to reach the simple system as we use today. And by the simplicity, it was able to put all the machines and the material into any truck or container and ship it at any place in the world. This allowed us to find lots of partners to produce the products in any part of the world, and also have with our partners together thousands of projects realized worldwide. Plus, we always didn't stop thinking about the current products itself. We developed new materials because the silo itself is not a solution for producing biogas. Therefore, you need other materials. So we are a technology-driven company, and we use, for example, our own material, Verinox. It's a combination of galvanized steel and stainless steel, allowing to have very high quality protection on the inside for especially biogas projects, where you have aggressive materials and gases that you need to protect the steel shell, the tank itself, from corrosion. Now, this in combination with patents and technologies developed around mixing and heating and providing more solution to the clients and the customers made us very successful. And also we share this knowledge together with our partners or joint ventures worldwide to allow us to make those high amount of projects, and we will still continue with that for the future.
I have to admit, when I first saw the video of how your system works, that it is basically this on-site construction of a whole tank, that it is built up from the bottom, I was really quite amazed. I always wondered how you ship a big tank from A to B, and now I see the benefit actually in the construction technology that you applied.
Exactly, yes. Here, the simplicity makes it successful.
For our listeners who might not be so familiar with biogas, can you explain, possibly in layman's terms, what biogas is and what it can be used for?
Sure. So first of all, biogas is a combination of two main gases. It's methane and carbon dioxide. Methane is about 60% and carbon dioxide is about 40%. So in essence, it is almost like natural gas, but with less methane concentration. So this biogas also, the word bio comes from as it's generated out of biological waste. And the way the gas is produced is very similar to our own body. So if we digest our food and organic materials in our body, also bacteria will split up the organic parts and produce energy for our body and also gases. Very similar process is happening in a digester. The digester is a core part of a biogas plant, which is a heated and mixed tank that is then holding lots of organic material where bacteria can grow. They like the heat, they like the food that's available, and then they grow and duplicate. And a byproduct out of this bacteria is the methane and the carbon dioxide. And this can be collected above the digester in a gas balloon. So we just close the tank and collect the gas on top. And now we have biogas available instead of the biogas going into the atmosphere.
I like that picture, what you shared. It's pretty close to our own digestive system, putting food in, biodegradable materials, and then producing all the gases, just like in humans and animals.
Perhaps I can add here regarding what to do with the biogas and why it's such a big value in this case. The gas itself, you can now again use and burn in motors or engines, and there you can create power, or you can use the gas for heating or cooking. So in this case, we also save the need of normal fossil fuels that is used in operations like this. In the Philippines, lots of diesel generators, for example, are used. And we can save a lot of fuel or diesel in this case if we use the biogas produced out of organic waste that is already available.
Right. And there is, of course, an abundance of biodegradable waste here in the Philippines, but I think we'll get to that in just a second. Because in partnership with the Philippine company MedPower Ventures Partners, your company is involved in building 2 industrial-scale biogas plants on the island of Mindanao, that's in the south of the Philippines. And the plan is to convert pineapple waste into biogas. So what is so special about this particular project?
Now, the specialty here is the challenging feedstock. Pineapple waste is not usual waste for biogas plants, as it's not researched as well as other organic wastes for biogas plants yet. So the challenge was how to use which quantities and which additional materials you will need for a working biogas plant with this big amount of waste. So we talk about more than 200 tons of organic waste out of pineapples for Dole itself for those plants. And that's first of all big amounts that we need to treat in the biogas plant and also build the infrastructure to use the gas that is then produced. Now, the gas that is produced on those plants itself can amount to a capacity of about 7.9 megawatt electricity, and that is almost a small power plant that you can run just out of the biological waste that is used for this plant. The 7.9 megawatts is equivalent to about 50,000 tons of carbon dioxide. And to give you a better example in a different number, that converts to about 18 million liters of diesel. Now, 18 million liters of diesel, you can run about 880 trucks per year, and that is almost 2.5 trucks per day.
Basically, instead of throwing the pineapple waste into the garbage and let it maybe rot on the fields, you can actually generate electricity out of this, and in doing so help the company to actually lower probably its electricity costs by converting garbage into electricity.
This is correct. It even solves another problem, because by this we can save the need of fossil fuels for heating. So Dole especially will need a lot of heat for their process in the production, and they don't need to haul this fuel in. They already have it available at the site, and they also reduce the waste that is trucked back to the fields. So we solve many problems with this biogas plant, even generating highly productive organic fertilizer. So this can be reused in the production of pineapples again.
Is it correct to say that since you can use biogas as a substitute for fossil fuels, that biogas actually has a benefit over other renewable energy sources, let's say solar and wind?
You can say that biogas is a very important factor in the combination of all renewable energies. The very big advantage of biogas is not depending on wind, and it's not depending on the sun. So you can produce energy or power 24/7. And if you combine all renewable energies, the biogas can play the role of compensating for times where there's no wind. You can start a biogas plant. So this is, for example, a solution if you can store the gas for a time and you stop the usage while you do not need it. And then you can run again the biogas generators, so you can produce electricity at the times where your other renewable energies are not producing as much as they should.
So biogas actually is a valuable and smart contributor in the renewable energy mix, and it should be here in the Philippines as well. Mr. Lipp, based on your many years of experience, what is your opinion about the biogas potential here in the Philippines? You mentioned a little bit already, but where do you see the future of biogas as a renewable energy source in the Philippines?
The big potential is where you have organic waste available, and you have also, which is often the case in the Philippines, no other power source easily available. So as there are many scattered islands, it is difficult to transport electricity or to transport fossil fuels to those islands, while often they have available organic wastes already, which is just dumped in some locations or on the fields. So while we can use the organic waste to produce biogas, we can also use the energy or heat that we can use the biogas for at those locations. And that is a huge potential for the Philippines in that respect. Plus the organic waste management from hotels or from other big cities can be collected and can be put together and treated in a biogas plant as well. So again, here we can produce biogas out of a waste that you don't want to have. So we again have the possibility to face two problems at the same time. And in all those goals, while we solve a problem for the or these locations, we can also contribute to achieve the climate goals of the Philippines and reduce the greenhouse gas emissions by 70% and increase the renewable energy sources up to 35% by 2030. That is an ambitious goal, and that can only be reached if we all use the renewable energy sources available as a package. And biogas plays a very important role for the Philippines, in my opinion.
Your examples already mentioned that there is a lot of waste in the Philippines that could be utilized to produce biogas. Also, the problem of the scattered islands. We do have a challenging infrastructure to reach those islands to provide them with electricity. But having said that, biogas only contributes a small percentage to the renewable energy mix in the Philippines right now. Why do you think there is such a low use of biogas technology at this point?
I think one important factor is the awareness and the use of the technology itself. It is not a commonly used technology in the Philippines yet. It's not in the mind of the people that this can be a contribution and help, and is not only an ambitious goal to reduce CO2, but it can solve a real problem at the locations where the people live and make their lives easier as well. I think it's a lot about training, also marketing such technologies to take perhaps sometimes as well the fear of such plans, and also to bring the knowledge to people how to operate such plants. Also, the operation is a very important factor, and we need skilled labor and knowledge for those operators. There's a lot of training that we need to do.
You mentioned the need to build up this biogas expertise in the Philippines, not only the technology itself, but also, as you mentioned, the trained personnel. Can you tell our listeners a bit more about the Biogas Technician project that is currently underway here in the Philippines and which is supported by the German government? How did this come about and what are the goals there?
We want to focus on the challenges that we face in the Philippines and promote directly and train people locally. So there's a lot of knowledge that we built up over the past decades in Germany, and we can share this knowledge to successfully then also integrate biogas on the Philippines. So what we do, and we as Lipp also share our knowledge with the people that we can reach locally, and the more people we can reach, the better it will focus on our goals to promote the technology, because then we find skilled people and staff locally that can help operating our projects. So the efforts are co-financed by the German government through a developed PPP project. And in cooperation, we from Lipp go with the German Biogas Association and the German Philippine Chamber of Commerce and Industry together. And we conducted a training on a bigger scale on the Philippines that was attended by more than 60 people. And we were very proud of the response to this training, that a lot of people were taking the course and were interested as well on the work on biogas in the Philippines. Plus, also this is an important goal for our plants in construction and our startup in Mindanao, to find operators and train operators on the technology, on the safety factors and operation on a biological process. So what we need to do in this case is we need to localize a lot of work that is often done in Germany. We need to find that analysis of substrates, analysis of the biology has to be done in the Philippines with short ways of transport to get direct results, much more easy with shorter waiting times, avoid shipping of materials. So once we have and reach that drive locally, it's much more easy to build further plants and expand the biogas business and expand the use of biogas in the Philippines or the different islands. So our goal will be, together with the German Philippine Chamber of Commerce and Industry, to train even more people for the future and raise the awareness towards the step that this technology will also be accepted and play an important role in the renewable energy sources.
So do I understand you right that currently those tests on the substrate analysis are actually done in Germany? So you're shipping material from the Philippines to Germany for that?
Yes, we did this in the past. We already built up small laboratories or equipment also in the Philippines, but for the past and the big equipment and existence of knowledge as well, how to do those yield tests as they are called, so to see the potential of organic waste that is available, is or was done in Germany so far. And this is absolutely necessary to do this locally on the Philippines.
It sounds that way. And I can only say that we here at GPCCI are proud to be part of this project, Mr. Lipp. And I can personally say that I learned a lot about biogas in the last few months. And I'm quite excited to see future developments and applications of the technology here in the Philippines, not only for, Lipp company and other biogas producers to get a foothold here in the Philippines, but also for the benefits in the Philippines when it comes to waste reduction, when it comes to CO2 emission reduction, and so forth. I truly believe, and you confirmed that in our conversation now, that biogas is an important and substituting renewable energy source in the renewable energy mix. And I guess there should be much more of it than there currently is. So all the best to you here.
Thank you very much. And I wish us all a very good success to raise the awareness of a biogas industry on the Philippines. Thank you.
Indeed. Mr. Lipp, thank you so much for taking your time with us here today. We greatly appreciate it. And we would also like to thank our listeners for tuning in today. If you have any questions about today's episode or any other GPCCI podcast, you can contact us at info@gpcci.org. We are happy to answer your questions.